Hello, I'm Ray. We're going to continue today our build of the dice. We finally have a tagline for this. The 3D printer that could, or the little 3D printer that could. It's very small, very precise, hopefully very fast. Yeah, so we'll get started. So, this is roughly where we left off last time. So we have this is the very, very top sheet. And we have motion in the X and the Y. Like so. And last time we had a few things that did not quite go according to plan, or rather that needed a little bit of touch-up. So, I think we'll just get started. So, here, and here. This is a bearing assembly, rather a flange bearing assembly. So if you look closely, you see that there's two sets. There's a lip there, 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 and there. So one belt will run through here, and the other belt will run through here. So, yes. And this screw is actually 23 millimeters. So you get a 25 millimeter screw in the kit. Please look. See, Torx M4 by 25. And then using a combination, in my case earlier today, of a bench grinder and a file and calipers and other items that caused there to be tiny stainless steel filings on my desk. Yeah, lots of fun. So anyways, you got to get the screw down to pretty much 23 millimeters exactly. But the thing is, you don't want to chamfer the end, because all that sticks out of here is 2 millimeters at the very end. And this is the 2 millimeters that's going to thread into the plate at the bottom here. And you need all the threads on those 2 millimeters you can get. So yeah. Now, if we're following the Dice Build Instructables, the Dice Build videos / playlist that's on the Instructable, or the YouTube playlist, then right now we would be installing one of these here on the left and the other one same on the right. And then we would be having a lot of fun threading the belt through at a later step. However, I spoke with Rene, the creator, and he said that I'm going to hate him very much for this belt threading step. And I said, we'll see. And then he sent me some hypothetical alternative directions, which I have in a hangout that I'm going to be looking at alongside something or other. And pretty much the idea is to think ahead for 2 minutes and have some fun. So I have belt. This is a GT3 belt from Gates. The company's called Gates, and it's the brand for this is Power Grip. It's very good stuff. So the dice is very precise, and I want it to run very, very fast. When you want it to run very, very fast and get good quality prints out of it, everything has some sort of contribution to that finished print quality. So if you use cheap belt, like the profile is the same. You could use a GT2 belt, which you can get for like 80 cents a meter from China. Or you could use, like, there's less extremely expensive or high quality GT3 belts. You can use normal GT3 belt, but then, how do I phrase this? I think it's like ringing. Like you might start to see some artifacting in the print, especially at the higher speeds, ringing. Like, I don't know, is that like when the corners don't come out right? So this belt solves that problem. Then also I'll just talk about the drive gear. If you're using like some cheap MK8 gear in the extruder, then your lines at higher speed, presumably, your actual extruded lines might come out, you know, all over the place. But if you get like a proper extruder gear, which is the Hobgoblin gear from E3D, that's, you know, another $10. But that's $10 that also contributes to having a perfect surface finish on your parts. Or, you know, get a full-on E3D Titan or a Bondtech BMG. Those are also very good extruders, but that's a more expensive solution. Very much worth the money in my opinion, but that's a more expensive solution, while using the printed extruder and just the proper, sharp, and properly machined $10 gear fixes a lot of those extrusion issues. We'll talk more about that stuff later. People who are watching, please say hello in chat. I would love to hear from you. So yeah, I'm just going to be looking over to the side a lot because I have instructions pulled up here. Anthony, hello. Thank you for tuning in and being smart about it. Good job. Good job. Cool. So, right. So, if we're following the official / older instructions playlist, then we install the flange bearings, aka the belt guides. We install them here, here, and then in the corners. And yeah, and then you gotta route the belt around all those places. And instead, we're gonna pretend that we actually know what we're doing, and we're going to pre-plan the belt path. Set it up, rig it all up right now, and then insert the flange bearings around it. Much more interesting stuff, I promise. Nah, not a promise I should keep, or not a promise I should make, because keeping that promise is going to be hard. Huh. I had a paper here that had all of the fasteners needed for each step, and it does not seem to exist any longer. So this is wonderful. More improvising. Woohoo! Cool. So, yeah, I'm just following along a large series of pictures right now, and I'm not going to cut the belt right now. I'm just going to kind of start one end, and we'll see how much is used, and then we'll see if a second half of that amount is available, and yeah, that'll be fun. So, very strong belt. If you pull it tight enough, you can use it as a guitar string of sorts. Okay, so it seems like our first path is just starting here, and it's hard to say whether I want to go in or out. But presumably they are similar. Yeah, we'll figure it out. Okay. Okay, so we're doing the top one first. The top one, we go in through a hole here. I'll show you. In the printed part, hang on. Now we're good. Crooked slightly, very nice. Not nice, but you know, very nice. Oh, that's offset. Wonderful. Yes, my countersinking manually, not so good. Get a proper 90-degree countersink. Don't use 135-degree drill bits to make holes for 90-degree head screws. Yeah, don't do that. You will ruin parts. So anyways, over here, we're starting with the top belt section, the one which is farther away from this sheet here, so the top one. We're going to go in and out, presumably, of this hole first. In, like so. so apparently we're going through, so in and out of the same hole. And it's very interesting how we're going to have clear belt movement considering the two sets of teeth are intertwined right now. Could like enlarge the hole somewhat. Curious to see what's going on here. Yeah, those teeth are definitely meshing, and that seems to be the extent of these holes. For kicks, I'm going to try the other side. Hang on. No, that's right. And if... Hey, I figured out what I did wrong. Okay, look. The side I showed you has two small holes, right? So this is for one section of belt, presumably. The other side has a, come on, focus. See? Ah, there we go. Larger hole, that would be useful for two sections of belt. So now I have to look at the CAD model and figure out why it showed me one thing while hypothetically I'm seeing another thing over here. If I hold the sheet like this, yep, I got my directions mixed up. Woo! Wonderful. Okay. So there's about 3 different things that are going to happen right now. I'm not sure if screaming is going to be one of them or not. Fantic, yeah, this is core XY. This is, yeah. This is core XY. Okay, so I can slide the rails off. However, then I have to realign everything anyways. So I don't necessarily want to do that. I can take this off, and that's what I'm going to do. So right now I'm unscrewing 4 screws on each side that hold the x-axis in place. I'll show you what the x-axis consists of in a moment. I wonder if there's an easier way to do what I'm about to do. Hey, there's a thought. Okay, so first of all, this is about to come off. Okay, so, one more. 2 more? 3 more. 4 more. Okay, all the screws need to change. So, my problem is I have the side with the 2 holes facing me. But what if I just flip it? It's all symmetrical. What if I just flip it? We'll see what happens. That's better than doing this and also taking other stuff apart and, yeah. Okay, so now we're not going to tighten any screw yet. We're literally going to go one at a time because we need to make sure that our rails are not going to bind. That's good. And I say we try 2 on the left side. See, that's already got more preload on it. Say we continue. Right. still keep tightening. Okay, so this is definitely tighter now, and by tighter I mean that there's more friction in moving the y-axis. Yeah. So the appropriate solution would be to redo, I believe it was step 2, 3, or 4, which involves loosening all these screws, holding the y-axis rails in place, and yeah. Seeing as how this is not the first mistake I've made, and it's probably most definitely not going to be the last, yeah, probably most definitely, that's the metric we're going with here, not going to be the last, I'm not doing this now. I will accept the slightly larger amount of friction in my rails, and later when things are actually working properly, I will go do a final pass again of tightening the y-axis rails. And then we'll also, after that is running very smoothly, pull one slotted nut out at a time, put thread locker on the screw, thread lock, and see, it's a good thing we didn't do thread locker now. Because at any point in time I could just move a little more this way, and then the carts would pop out. Cool. Fantastic, thank you. Yeah, there's a Dropbox with a bunch of stuff. I have a CAD model going on my laptop here, and yeah, there's the subtitles, there's the YouTube videos subtitled in German, so yeah, lots of fun. Okay, there we go. So, which way? This way, okay. Which way? This way. Okay, yeah. Yeah, I've got a rough setup in this general direction of things that are not going to happen properly here, for sure. So, once again we try. I have the main plate. The arcs are facing towards me. I'm doing an experimental, never before tested on an idiot, hello, belt stringing procedure. So it will come in here. Now we have the larger side here where two belt paths would be available. We're going to come through here. See, now we can jiggle freely, more or less. Yeah, just enough clearance. I'm going to take the belt path out here. We're going to pull quite a bit through. Because we're going to have a flange bearing here, so that's going to be our first loop. Next. 2, 3, 4. Yeah. 1, 2, 3, 4, 5. Huh. We keep going. Now it curves around here. And again, we're stringing the top, so I only have one hole here in the top to go through. And then we're going to come out here. Again, this is a static point. This is going to get cut pretty soon. Two bearings here and here. Okay, this is going to come out here. And then last one. Yeah, it ends here, obviously, because it's going to go inside here, and I think, yeah, the belts eventually get glued in. So this is wonderful. So let's just pretend that we're about here. About yay much. And we're going to glue the belts together, like so. Or not glue, I'm sorry. I'm just going to zip tie them and then I'll cut them. Which involves finding zip ties. I have cutters, I need zip ties. I have boxes. boxes of items. Woo! Cool. So, one loop here. Mainly, I want to check that I have enough to do the other loop, or rather, how much is enough I have. Yeah, just about. Yeah, so I don't have, too much available for slack here. Okay, so this is going to be one motor. It's going to be in this general vicinity here. Oh, and they're showing a lot of slack, actually. So that's about as much as I feel comfortable giving. That's about yay here. So, here. Next, before I cut here and string the other belt, I'm essentially going to just follow this back and see if I have enough to replicate this. I do have enough to replicate this, and I actually have a little bit extra, so I am going to give a little more slack here. Okay. And we're going to try this one more time. Yep, that's perfect. Time to get the cutters. And by that, I mean walk over to the desk and pick up the cheap blades already warped $3 flush cuts from Harbor Freight, about yay much right there. Yeah, absolutely no chance of a clean cut. No. Yeah, that's the idea. So that's one belt with some amount of pre-planning. See, already popped in. Pop it in. Secure the zip tie better. Cut the zip tie. Be done. So yes, here. Here. Oh, and we can. Cool. Belts are probably going to ride on the inside of here, and other belts are going to secure into the belt holes there. Okay. Anyways, next step time. Now we're going to do the second belt. The second belt involves, well, definitely something. It looks like I'm going to come out the big hole in the bottom here and go left, or right. It's left for someone. Picture 2. Okay, so that's going to end here, and everything else is going to be this other here. So we'll go back. And if we're going back through, that means we're coming out straight out. So that's going out the back. Okay, here, back. Next, picture 3. Okay, so we come around. Yeah, I get the idea here. Picture 4. Yeah, we come through the middle here. And picture 5. Okay. So we're going to come through the last available hole at the bottom here, and now we're going to come left. Oops. Yes, we have slightly more length on this one, or it's just curving differently, or whatever the case may be. And zip tie this one now. Zip tied, cut, tossed, drink, Continuing. Okay. So now we also have an alternative way to install the flange bearings. Here's roughly the idea. Let's get some stuff out of the way here. We have these things, right? Remember our little ear, if you will? We have three, I know the contrast here is probably not the best. Thank you, absolutely no dedicated lighting whatsoever. We have three pieces of belt here. We have the one that goes full through from front to back, and then we have the two half loops, or whatever, the two curved pieces. And that's all going to get shoved inside here pretty much, because the little flange bearings, that's what the two ladder belts are going to run into, or run in, I should say. Huh? Is that right? Yeah, that's got to be right. Ah, it's crossed. Wonderful. Cool. Learning stuff. Four of these things. I think I'm also supposed to install these. I'll do it soon. It's okay. That's probably going to be the next step. But Renee's pictures are showing with these blocks, these 4 blocks already installed. So, you know, we'll catch up. Okay, so lots of fun. Take a deep breath and proceed. Okay, so we're going to do one practice run, because we have to take this, we have to shove it on the inside, and we have to not lose anything. And then when this works, I'm going to take it back out. I'm actually going to do it for real with thread locker on the screw. Fun. Right now I'm just thinking about what I could use to prop this thing up. And of course a prime candidate for that would be the can of WD-40. So we're going to go almost vertical. I guess 60 degrees is almost vertical, more than half. Ah, it'll tip. Wonderful. And I'm just going to give this 2 turns. I just want to make sure that the thread's engaging, that the screws go into the right place. It's not, but you know. Yeah, this is way out, so let's kind of get that. See, we can't lose the washer either. There's a washer at the very end of all this. We can't lose it. It's very important. Okay, so the thread is now engaged. And I put this out of the way, and I reset all of our stuff. Then after that, I have to install 4 screws. I'm going to do a quick, I don't know, halfway thread them in right now. I want to make sure that all the screws are going to bite. This is just threading into plastic. Oh yeah, this is the one where the 2 screws are indeed good. On the other side, I think this is the correct side, is where 2 screws weren't biting and I had to go in there, or I have to go in there, and clear out 2 holes. Yeah, the plate is not lining up with the holes under it. This is wonderful. These 2 are good. Make that 3. and 4. That'll go. Okay, cool. So if I start them in a counterclockwise fashion, they'll bite. Cool. And then I'll clean up the other side later. Okay. So now I get to pull this all apart, clean it up, get thread locker, and do it again. Let's get started. Cool. So, prop up. This is all just coming apart. The washer's still caught inside there. Perfect. Okay, thread locker. Tiny, tiny drops, not more. We don't want a puddle. We don't want a seam. Just want a little bit. Loctite blue, 242. 243 is for slightly dirtier applications. That's what's used in the official instructions. 242 is fine. Clippy a little bit. I'm trying to get like the minimum amount of flow out of this. I think that opened it. Okay, that made a big puddle. Okay, let's dab it. Yep. Tiny, tiny amounts. And now we're getting more on the washer. That is a lot. Okay. We definitely do not want this going into the bearings. That's going to have to do the trick, guys. Okay. Now, let's prop this. Let's get it up. Let's get it in there. Ah, okay. We just lost everything. Prop this up. Clean the washer. Pretty sure I lost the washer. Nope, but now I lost the washer. Let's try it again. Come on, we got this. I apologize, there's absolutely no good way to get this on camera right now. Okay, that's engaging ever so slightly. Cool. We're going to maintain friction. Close up the Loctite. Start getting these screws in here. Then we tighten up that middle one. So starting top left. Might have been a good idea to read up about how long this takes to set. Okay, tightening. Now we're going to go diagonally tighten. Okay, 3. I'm going to pop this in the drill. apologize now for the loud noise that just happened. More drill sounds incoming. Okay. Precariously perched drill, wonderful idea. Okay, tightening the big one, doing it manually. Now we have to make sure that both sets of flange bearings still spin. We're going to now take a moment to read about how long this takes to okay, it's set in 20 minutes, so we definitely have more than 8 seconds to get the installation to happen. So now it's good to know that. And in 20 minutes, it'll be a good idea to verify that we can still spin, in particular the lower flange bearing. Yeah. Cool, so we have one belt, and we have two belt, which runs over this. Wonderful. Cool. Now we have to do the same exact thing on the other side. A moment of peace is in order, and while that is ongoing, we can do some fun stuff, like making sure that all 4 holes are actually clean enough that a screw will enter them properly. Drill sounds. Just a moment here. Yep, just had to, excavate some plastic crud from those holes. I did tap them M3 earlier using the combination tap drill item from Harbor Freight, but there was still a couple of spirals left inside, at least one of them, not 2 screws, so yeah. There's going to be a lot of compressed air involved in cleaning all this up after the fact. We don't want to have any sort of specks contaminating the rails because that's a great way to have problems. So we're not going to do that. Okay, now I'm going to put the screws through to make sure that we have the threads. That would be a yes for the first one. That would be yes-ish for the second one. And it goes in, that's the important part. Third one. Yep. Remember, as the saying goes, how does the saying go? Well, it's something to the extent of, don't worry, it gets much worse than this. This is fine. I'm told that this way with the belts is much easier because you don't have to thread anything. Although I can see how that wouldn't be horrible now that I understand how all the paths are supposed to go. But the caveat is you have to force them to get the flange bearings in place. Alright, let's do this. Give these a quick spin. We're good. Okay. Go sideways. Give a tiny dip. There we go. Huge amount of blue thread locker. Wipe as much of it off as possible. And then prop this up, which should have been done ahead of time, really. And in a manner of speaking, go to town. So we have to get all this in here. Good news is we have time. We have a whole, I don't know, 10 minutes to get this done because it takes 20 minutes to set. It does help if you can actually see where things are going. That's always fun. Alright, so I do see the threaded hole and I can see that I'm nowhere near it. And that sound would suggest that we just lost our washer. Wonderful. Wonderful. So, yeah. This is here. That's there. Okay. We're down a few parts. One moment. My closet of printers. Okay. Apologies for the loud noise. Alrighty. It's a good thing we have 20 minutes. Not anymore, but yeah. That's clean. This is mostly clean. It's good enough. Other washer. Alrighty, let's get to it. Helping it into place. That's all. With quite a bit of pressure. That's the fun part. Pressure is the fun part. That just escalated. Keep losing the washer. This is fun. Interesting. I think my inability to properly apply thread lock is the least of our worries here. Yeah, that might help. But remember, this is a very specific screw. Well, it's a 25 millimeter in the kit that I then had to go grind down to 23 millimeters length because everything has to be flush. So the Loctite dot would probably get lost along with plenty of other things in the grinding process. Hey, I engaged it by accident. Woohoo! Alright. 3 more screws. These are M3 by 10. They're the quote-unquote countersunk type. Which in American McMaster car terminology means flat with a Torx head. For consistency, I'm going to start them going clockwise, and then I'll tighten diagonally. Who else is in chat? Please say hello. Or who else is watching? Please say hello in chat. So, yeah, lost the screw. There we go. Okay. Third screw, fourth screw. Record time. With everything falling apart, we still got this side assembled in roughly 6 minutes. That's one. That's two. That's three. That's four. Going back for another tightening pass of 1, 2, 3, 4. Now I have to make sure these still turn. Yep. And then I have to tighten the middle one. Hey Mark. Thank you for joining. Yep, 1 turns, 2 turns. We'll revisit in 20 minutes and make sure that they still turn after the Loctite is set. I don't see any on there, and since we've tightened the screws, we seem to be in good shape here. Yep. Guys, this is the first hard part of the build, and it seems to be a success of unknown proportions, because I don't know if I actually did it right. But it can seem to be a success for sure. So this is a wonderful, wonderful thing. Woohoo. And you keep seeing the top of my head. Yeah, okay, cool. So that concludes the deviation in instructions for the new way to do the belt. So, it really, 2 ways to do the belt. The normal way to do the belt that's documented in the videos is you install the flange bearings first. It's easier when the belts are not pushing out on you. And then you thread the belts all the ways with no access to the inside. So you gotta go from here to here, yeah. That's way number 1. I say get a pair of tweezers, get it done. Way number 2 is what I did, which is you thread the belts ahead of time. Either way, you have to understand like the core XY routing principles, and you have to understand the belt path. It's a core XY, so there's 2 levels. There's an upper belt path and there's a lower belt path. Each one is 1 open loop, which we've temporarily zip tied, and later we're going to finish. Yeah. So on and so forth. So both ways have their merits. You saw the difficulty with getting the flange bearings in this way, but now we don't have to fiddle with belts. So this is good. Okay. The way we were doing the build in the past is I have the YouTube videos open, and I don't need to hear the spoken German. I can fail to understand that on my own time. I just kind of watch it and follow along the subtitles, and yeah. So, yeah, let's do that. Here we go. So flange bearings on the lid. Flange bearings to the frame. Yeah, that's what we want. Okay, so this is now the continuation of step 7, which is roughly halfway where I left off the last stream. I'll explain everything in a moment once I change from German to English subtitles on the YouTube video. So we need a metal ruler, which I still don't have. Give me a minute. Okay, so I do have my paper of fasteners. This is good. I do have my water, from which I will take a drink. quarantine the WD-40 to the floor. Alrighty. So there's going to be a few fun elements to this. Flange bearings, frame, 23s are here, and 6. Lid Y carriage. Yeah, I'm going to watch step 6 real quick. Make sure I understand it. Yeah, okay. So the normal step 6 is what I was talking about. It was installing these two plates with the flange bearings and the thing. Yeah, the lid of the Y carriages. Right. But we did that and our belts are done. Woohoo. Cool. So this is good. Mounting the flange bearings to the frame. Step 7. Yep, this is good. So we're going to need a metal ruler or a steel scale to use the German translation. We need these 4 blocks. These are aluminum, they're CNC. They have holes in all the sides pretty much. And the holes are tapped. So it's kind of like using a block that tells you where everything goes so you don't have to guess. So this is cool. Yep. Oh, I also learned something. 2 days ago, last time I streamed, I referred to this as a pressure part because that's what the subtitle said. Apparently in German the word for pressure and the word for print is the same thing. So this is actually referred to as a printed part, which makes more sense because I thought it had to do with pressures being applied in various axes and whatnot. So that was fun. I learned something. Happens every day. So we need the 4 connector blocks. Tapped, milled, beautiful stuff. Give them a nice little shine too if you want, you know. Okay, we need these screws. We need 7 M3 by 8 millimeter. We want the cheese head. Cheese head is not countersunk. Cheese head is like button head. It's a button head with a Torx bit, for a Torx bit. M3 by 6, M3 by 10 is different. M3 by 8, woohoo, finally a use for these things. Okay, and we're going to need 16 bearings, which is all that's left. I got 10 in this one, 6 in this one. These are the remainder of the flange bearings, the MF104s. Let's move everything to the left so you can actually see what I'm doing. So, 16 bearings, 8 screws. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Great. All right. So we also need M4 by 40. We need 8 of them. M4 by 40. This is also, oh, this is a plain button head. Yeah, this is just a normal button head. It's not. It's just for an Allen key. It's not even. 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be the entirety of this bag. Get it started. Alrighty. Continuing to watch the video. The flange bearings are going to go on these screws. Now, as spacers, we're going to be cutting up sections of this air hose. And this is going to provide some compressibility and the various spacing. Yeah. So 4 millimeter inner diameter, 6 millimeter outer diameter. We need 4 pieces that are 4 millimeters long 8 pieces that are 13 millimeters long, and 4 pieces that are, I believe, to be 22 millimeters long. Okay, so I brought blades. Now, first of all, I want to find the more skew. This one's more diagonally cut, and I'm going to give it a tiny straight cut, straight down. And this is hard to cut. This is stiffer than I thought. I thought it would be way more compressible, but maybe it's just my knife. Let's try a different knife. Totally the knife. This cuts like very, very stale butter. Does stale butter get more crispy, making it harder to cut? Is that a valid analogy? Yep, this will work. So I'm using a bit of a sawing action to get a clean thing. And I'm just going to use my sacrificial file and just give it a few gentle rubs. Because I want it to be smooth. And it's definitely not smooth. So, for cutting, I originally envisioned having printed parts. See, there's a channel. I need to put this in. 4 millimeters long. However, this is the wrong size because my brain works so well. And I also did not have time to make the rest of them. And if I had, they'd all be wrong. So we're just going to use calipers and we're going to do it manually. So, zero this thing out. Get these screws out of the way. Get this out of the way too a little bit. Dun, dun, dun. 4 millimeters. 4 millimeters. I'm stuck between 3.9 and 4.1. Wonderful. 3.99, 4.0, yep, that'll work. Okay, so let's try something here. Yep, that's right on. For the 4 millimeters, I am going to see if I can make this work. My little printed piece. You know, without injuring myself too much. Just shaving the edge down a little bit right now. Alright, and I don't know what I had in mind here. I thought it would just, yeah, it does that a little bit, but not much. Yep. Let's see how close to 4 millimeters this actually came out. As we shall say, close enough. That's not actually, it's more like 4.12. It's, yeah, I'm forcing it in. It's not smooth. Alright. On 4. We got this. Okay, so we can even go a little under. Alrighty then. We need 4 of the 4 millimeters. So we'll just keep going. Put it under the caliper. Pressed against one side. use the other lip to get it started. Give it a flip. Yep. That's 3. This table will have many more cut marks in it in the next 30 minutes. Sorry, did I say 30 minutes? I meant 3 minutes. Or hours. You know, this stuff takes me a while. Alrighty, come on. Alrighty then. That's 4 of the 4 millimeters. Water. Oh, Next. Okay, so next we want 13 millimeters. We're going to want 8 of these. So we're going to take extra care to do it wrong. And so we can keep repeating. 12.98, 13.04, 13.05. Definitely moving in the right direction here. 13.00. Woo! I'd really love to just be able to get in here with a much flatter blade like this quote-unquote X-Acto, but yeah, it's biting. I need to put, yeah, I'll get some cardboard. Yeah. I don't want to cut up my table. Alright. $13.00. Start. Yeah, you can't just apply pressure to this. You actually have to use a sawing motion. So this is now 2 of the 13s. And we'll just keep going. But at least in this position, actually, you just want to get it started. And then once that happens, I can apply the sawing motion and life is better. I mean, I'm building with dice. Life is already good. Now, if you're using a real X-Acto knife instead of the little $3 dollar store version, then things might work out even better for you. I don't know where my real X-Acto is. It's in some other box somewhere, in some other room. In this house, though, not some other house. This house. That makes 4. Makes 5. One sec. Okay. That would be the remote for my camcorder. May or may not still be alive. We'll find out eventually. So, 7. 8, I think. 1, 2, 3, 4, 5, 6, 7, 8. Yep. And 4 pieces that are 22 millimeters long. First of all, we're not at 0 anymore, so that's wonderful. Let's actually check some of these. Alright. With some compression, that will be 13. That's 13 and a half. And these are going to need some filing. This is way off. Yeah, the cuts are crooked. This is wonderful. That's just not going anywhere. Okay, what I just did, trying to cut like some tiny sliver off of this relatively stiff air hose, is a great way to lose a portion of a finger. So we're not going to do that. We'll figure it out later. We're at 0, and we're going to go to 22. 22. .01. Yeah, don't worry. Our overall error is way greater than that. .22 piece 1. .22 piece 2. .22 piece 3, 22 piece 4. Aye, that's going to be clipped. Oh. Alright, 22 piece 4, cardboard, looks like somebody raged on it. Put the knife away, clippers, cardboard, extra air hose being set aside, and we have many pieces. Okay. Word of caution that as you move the cart, do not go all the way down because the cart will pop off the rails. The rail ends here, but the cart can move more, and then you could lose the balls. So we're not going to do that. All right, so right now we're going to assemble the blocks. The blocks. The blocks. Now my understanding is that they go like this, and they seem to be symmetrical. And the holes seem to go full through. So this is good. One, holes there, cool. And per usual, I do not over tighten anything. Cool. Yeah, so I'm going to do this, and then I'll go finish the video and see if I did it right or wrong. Hey, a washer just fell out. That would be where it came out of. That's wonderful. Yep, lost a washer. Lots of fun. Cool. Ha ha ha. Let's see if I can get the screw out. I can. Let's redo this. Cool. Yep. So, potential addition to documentation. After finishing that last step, when you install these, shake test everything. Plastic threading will be very loose by the time we get this right. This is what I get for using the word quarantine in regard to the WD-40 can that was holding all this up. It got offended, it wished this upon me, and that was that. Alrighty then. 4 of these screws coming back out. Switching over to the larger bit. We're way past the setting period here for the Loctite, so this is all just, you know, whatever works. I'm going to try to prop it against the drill this time, see what we can make happen. Okay. That spins clearly. Do this, this. Okay, that just popped out and we just lost the washer again. Wonderful. Yeah. I think a dab more thread locker is in order, and there will be multiple dabs by the time I actually get this right. Yep. Great, I finally learned how to give it just the tiniest amount, and then I gave it more. Woohoo. Woohoo. Okay. Boom! We have engagement. I think, maybe a little bit. Let's get these plastic screws going. There does seem to be a washer there this time. I'll check again in a second. Definitely a good workout for the hands. Okay, I'm going to do the shake test now. Okay, I do see a washer in there, so hypothetically this is better. Okay, once again, we're going to tighten the 4 screws around the corners that are going to the plastic. I'm going to tighten in a cross or a diagonal pattern, as you want to call it. And then we can go back to that next step that we were working on before this happened. Okay, diagonally. Don't want to overdo it because it's just plastic. It's not like there's threaded inserts or anything going here. You over tighten, you remove the thread, you're done. Cool. Shake test. Cool, we're good. Alrighty then. I'm going to prop it up on the side again. You can use the wonderful drill for this. Notice my nicely used puddle of Loctite here. Great use of Loctite. $5-6 for that little tube, and yeah, more of it ends up on the paper towel than on the metal threads themselves. Wonderful. Okay, so with the blocks, the idea is very simple. We put a screw through. Presumably we put a screw through, I hope. Hope that's what happens. No need to tighten anything yet. Just get stuff started, you know. A good way. Being gentle, make sure I don't want to cross thread anything. The tiniest amount of engagement is all we need. It does seem to only want to secure one way. So I'm not leaving it loose, but I'm not tightening it either. Just finger tight, as they say. So that's that. We can do two more on the far side here. Hello. Yeah, it's finger tight. Cool. I suppose I could put it this way. Put it on the side. I don't want to put it 180 degrees because then the carriage will fall, slip out, and life will get even more interesting once again. Cool. So, third side. Cool. So what's everyone doing right now? I assume I'm not taking up anyone's full attention span while I secure one piece of metal to another piece of metal repeatedly over the course of 3 hours. Cool. Going back this way. Third side, fourth side. Cool. Yeah, not much room for interpretation when it's a laser cut hole to a machined part. It's all pretty clear, you know. Done. Here, look. Block, 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 block. Carriage. Printed part that will eventually go on carriage. Not pressure part, printed part. Woohoo. Alright. Now I get to scroll forward in the YouTube video somewhat. So, achievement. Now we can do this, stand it up. It's clear. We can move. Very cool. Again, do not go all the way to this end. Orient yourself by these arcs here. Do not go all the way to this end because the carriages will pop off, you'll lose everything. in a sense, you might lose your balls. So don't do that, because you do not want your carriages going off the rails. You do not want the balls coming out of the carriages, and this will be fun. So now the video is showing how one should cut so that the surfaces are actually square instead of salami sliced at a diagonal. And, well, obviously mine are diagonally cut. Like, what would you expect? So, I don't know. Not much room to actually clean this up. The file didn't seem to do much before. Dimensional stability here is just a complete myth. I can potentially clip them a little bit. But yeah, there's no way we're getting this, you know, to be stable. So naturally I'm just going to do it as is, and we'll figure it out later. Tomorrow I can find out how I did everything wrong, and, you know, I'll take it from there. Ooh, maybe a tubing cutter would be a good idea. That's not expensive. Yeah, a tubing cutter. That's a part worth having if you're going to do this. You saw how much I struggled getting it right. Okay. Let's check this out. We're going to orient everything this way. I'm going to move the cart down. We're going to get the ears out of the way. So we have the thick hole the belt comes out of on this side. Hang on. Okay, bottom line, we want to put an M4 and put it here at the hole right above the rail. See, right above the rail. There's another one above that. Apparently we're not doing that right now. So we're just putting that. I think we're going to put a piece of 13 millimeter. Hang on. Yeah, that's a 13. Oh, once it goes on, because it's 4 millimeter inner diameter on the hose, and it's a 4 millimeter screw, and it's good enough. I think that's going to hold it in place. It seems like we're also putting another screw in right above it, in that second hole, and I gotta get a clearer shot here. Yeah, it's not holding. Okay. Okay, got it. So we're putting all 13s right now. That's a 22, that's not a 13. Putting all 13s right now. So 13 on the bottom, then we're going to use our flange bearings. And the way this works is we do them in pairs. So this is how a flange bearing comes. It's this, and it's got that lip on the bottom. So we stack them, so one's lip is at the bottom, the other's lip is at the top. And you get this nice little belt path. I'm going to do that for both of them. And then it seems like we're putting more 13s on top of them. And there's some compressibility, and how do I say it? There better be some compressibility, because I need to compress this, and that's still going to go. That's fine. But do they line up? Absolutely not. Should they? Oh yeah, they should. And you know, they don't. Got it. So this is presumably for something. Who knows? We'll find out eventually. I don't know. But these are the same height. On the other side, I'm going to put both screws in right now. And then let's watch. Yes, the side where the hole's above the cover, right? So we're going to put a 22. And again, a 22. Now we're going to put the flanges on. Bottom, up. I'm going to open up my other set of flanges. Got that. And we're going to put the little 4mm on top of that. So far so symmetrical, very nice. Okay, so these are at like the medium height, and these are at the high height. Cool. Next. Now the other side, well, we may as well finish this off. So I'm going to install all 4 screws right now that are left. Alright, let's get this clear. Come on. Okay, good. Phew. Alright, these are all through. Alright. Okay, let's hold this thought for a moment, because this just got complicated. So this is the side where we use the 13mm ones here, the 13mm pieces of hose here. Now I have to see, because there's one belt here. Yeah, the subtitles don't 100% match up to what he's pointing to, so It looks like you put a 4 first. Yeah, let's just wing it. So if we put a 4mm on each of these. Huh. I don't think that'll go. I'm going to need to get a side view. Lift it up, sort of. Huh. Interesting. On this side, it looks like we're using the 13s. On the lower left. Let's get that out of the way. Flange bearings. And another one on top. Ooh, this stuff is tight. And very much so on top of each other. That doesn't seem to make sense. Yeah, that's no good. Nah, those are the right holes. Yeah, these are offset. Okay. Hang on. Something's not right. Okay, no. So we're using, I guess, a 13-13 on the inner hole. Yeah, I can't explain this, so I'm just going to give up at some point. This might be a 22. Yeah, there's the offset. So that would have to be a 22 here to offset it. There, right on top of each other. And then a 4 on top of that. Okay. So far, so horrible. No problems. Now, let's see if I can get a view of the other side here. That did not work. Okay, I think the 13's on the outer. I'm just winging off what I see here. 13mm hose on the outer because it seems symmetrical and I can't see the other one. So I'd have to assume that it's a 4 on the bottom. And a 22 above it. I mean, that does sort of fit. Sort of. That is not a... Okay. Okay. I have no idea what's happening here, but we can give it a shot. Cool. Oh, now 13, that's a good hit. This, not so much. No, I don't see this happening. I'm going to do my way, which involves a 13 on the inner, seeing if that fits better. That definitely is more conducive towards where the belts line up. And then 13 above that. And then we're also going to do a 22 here. If that's how he wants it. If he wants the belts to be the opposite manner, then that flips everything. And that will be a lot of fun. So the takeaway here is try to find some other demonstration of this that actually shows what's happening. Yeah, that's good. That's tight. That's one belt. That's good. Woohoo! That actually makes sense. There is the one loop, and then there is the other loop. And if that's correct, that would complete step 7. Are we putting like a nut on them or something? No. We're going to do the second plate, I think, with the motors. This will be fun. Guys, we're getting somewhere. This right here, which I'm afraid to lift because everything's going to fall out. We have our majority of our motion system here with the threading actually makes sense to some extent. Like this is going to go here in some order, I would presume. Or maybe it's going to come around. I don't know how this stuff's going to work. But yeah, this could be like this. I don't know. Things could happen. This could just be like this. And that might be the extent of our motion system. Woohoo! Cool. So, the next step involves mounting the X, Y, and Z motors. And I have to set English subtitles again, because I still don't speak German, but I have been learning words. Okay. So, for this step, we're going to need 12 M3 washers. 12 something that I don't know. Yeah, the translation got really stuck. 12 M3 washers and 12 M3 by 6 cylindrical head. Okay, so that's what we would call a normal socket head in America. Okay, let's do some cleanup. We have our empty bearing tubes. Bye-bye. I have a strong feeling we're going to be using this plate, so I'm going to bring it over. Here, look. Enjoy the nice plate. Enjoy the shiny, oily plate. It's a nice plate. It's a nice plate. You know how some people have pets and they enjoy petting their pets and otherwise being affectionate to their pets? I'm enjoying this plate right now. It's a nice plate. Okay. Yes. Okay. I'm gonna see, it's also in some capacity probably gonna go on top like this. And we're gonna be installing motors here. See? Cutouts. Motor X, motor Y, or in Core XY, they're all interchangeable. Z motor. By a useless printed part. Okay, so a little bit of cleanup. We're going to get this motion system out of the way. You graduated. Congratulations. It's more than I can say for myself. Okay, cool. Let's get some more paper towels so we don't scratch up this guy. Typical notes include the fact that we'll figure out the proper orientation of this. There's usually a crappy side from the laser, which we can see right here, the side with all the splurf and the various grindings and the not so good surface finishes. And then there's the other side, which is very shiny. Now, the question usually ends up being, well, which side is which? This side is more shiny, so we're good here. Okay. Okay, so we're going to need 12 M3 washers. Here's my bag of M3 washers. This is done. And we need the M3 by 6 socket bolts, the normal socket bolts. Hello, we got you. Okay. And we're going to be using 12 of each for this step. Here, see? M3 by 6, not button, socket head looking things. M3 washers. That's the word for washer right there. I'm still not confident in my pronunciation, so you know, we'll work on that eventually. Yep. So this is the sheet we're going to be using. This is the way it's facing. We're also going to be finally breaking out our motors. So, 2 NEMA 17s for our X and Y. Regular, oh yeah, these are the 40 millimeter long for both of them. And then our Z-axis is very special. It's also a NEMA 14, I'm sorry, a NEMA 17, but it's 34 millimeters long in this dimension. And it has the lead screw built into it. And this is a TR8 by 4, so the lead is 4. It means every time this turns 1 revolution, the nut is going to move up 4 millimeters, presumably. Yeah, that's about right. I'm going to be taking the nut off a little bit. Oh, by the way, by default, if you look at the BOM, this comes, it's much longer. So, hacksaw. Clean up. Nice. And then when you hacksaw it, it's more difficult to get the nut on in the future, and you got to get the nut on straight without cross-threading the thing. So lots of fun. I'm going to leave it like this for the time being. Okay. We're going to need normal hex for this, finally. Yeah, we don't need a Torx bit this time. First time I can say that in this build. Yeah, no, it's not a Torx. It's a regular Allen key, for which we have this other item from Harbor Freight. And I seem to think it's a 2.5. Nah, there we go, 2.5. Let's see if this does the trick. Heyo, yeah. It's a nice 2.5 millimeter hex bit. That'll do the trick. Cool. Okay, apparently we're going to be grabbing one more plate here in a moment, and we're going to be double checking a fit. Let me get this other plate. This plate is a vertical plate. It's 4 millimeter aluminum, see, thick, instead of the 2 millimeter stainless steel that the other sheets have been. This is going to be perpendicular to this plate. In some particular orientation, this is going to stand to this. The lead screw for that Z motor is going to be behind here, and then the bed holder comes through and rides up and down in this slot here. So we have to check something. And now I can stop speculating and I can say that this comes through here. And it goes into these little squarish cutouts here. And we hope that it fits. And it does seem to fit very, very precisely. Okay, controlling all the sides. Yeah, I mean, it fits. Is it perfect? Not quite. Beautiful on the edge, right here. Nope. Okay, let's do a flip. That's closer. That seems to be as good as it's going to get. That's very good. That's not so good. It gets there, yeah. It's got a fillet on it. Oh well. Oh, the laser wants to make a 90-degree corner here and here. It's not doing that. That's a fillet. That's not a 90-degree corner by any stretch. So we want a very, very sharp corner here, and we're not getting it, which means we need to break out the files. Where do I have the files? Hello, files. I'll use a flat file. I guess I'll that's already looking good. And here. Getting there. That's closer. That's also very good. You know it's very good when you've got metal shavings all over your fingers. That's how you know you're doing everything very, very correctly. Okay. And this is how we get a correct, beautiful look. By whose standards? Different question. Different question. So, yep, so now we check this again. Yep, that's good. That's as good as it's going to get. Perfect. This side. Right. Hang on. Okay. Let's see where a screw went. The NEMA 17s get mounted above. Above? Motors are underneath. So bottom line, you get a pretty side, and the pretty side is going to be the really pretty side. This is going to be my pretty side. Okay. So, NEMA 17s. Apparently the cables should be coming out the sides. And we'll be doing this sort of thing here. So, with the washers, there's a sharp side and there's the side with the fillet on it. The sharp side goes to the plate. 2, 3, 4, 5, 6, 7, lots more. Okay. Let's do this. And screws. M3x6 socket head. Again, not tightening anything here, just want to get it loose enough but that it'll hold. Sharp side of the washer to the plate always. Not even remotely tightening anything down right now. That's banged up. Alright, I don't think no one's looking there, hopefully. One. There's two. Not even tight. The motor wiggles around freely. Both of them. I'm just finger tightening. I can still slide them. Clear. Okay. Fast forward in the video, past the part where I assumed I know how to screw a motor into a plate. Maybe I do, maybe I don't, who knows. In a different life we might find out. Anyways, we're going to be doing the Z motor in a moment, I can only presume. Okay. Z motor. I'm going to take the brass nut off now. We're going to be very, very careful with this. We don't want to bend it or anything. It's very gentle. Z motor is going to come in like this from the other side. Now we can prop it like this, like so, at an angle. It seems like the cable, we want the cable coming out the bottom, which is an interesting mounting question, which means I'm going to be working very much so up against the edge here of my table. No. Side? Yeah, this is where the subtitles combined with my brain makes things a bit confusing. Trying to figure out which side of things we want the cable coming out. Okay, let's pretend we know which, this is the rear of the machine. And let's look at the CAD model. This is the rear of the machine, and the extruder this plate is mildly symmetrical. This is our back plate. Yeah, we could have it so the extruder's on this side, which means we want the cable going that way. Alright. Yeah? No, that's not right. This is the outside. There we go, it's holes on the bottom, holes on the top, which means... Hang on. Brain needs a little help. One moment. Okay. This is on the right. These double holes are the top. The CAD model has this is the motor mount for the extruder. In the CAD model, it's on this side. All that means is that this is relatively symmetrical about this axis, right? It just means that somebody countersunk the holes on this side of the sheet instead of this side of the sheet. Which is cool because this is the side of the sheet with the big laser splurf, so we don't want that to be out the rear. So, yeah. So the way this is going to work is this is the rear of our machine. This is the rear of our machine. The extruder is going to be on this side. I want my cable exiting that way. Woohoo! We finally figured something out. See? It's all variable. And there's also the fact that I have no idea what I'm doing. That helps too. So, we'll do this. this. Works for me. Going to be a lot of zip ties involved in clearing that up. Four more screws while I watch the video about how I'm doing it wrong. 1, 2, 3, 4. So yeah, 4 remaining M3 washers and 4 of the M3x6 sockets. Pair them now. I like when things line up. It's good. Again, we're not tightening anything right now because the motor may need to be wiggled a little bit. And indeed the motor is wiggleable. So yeah, we're not locking anything into place yet. Put this up, and we'll get a 4th screw going. Okay, so we can make a judgment, loosen everything. And we can align this so that the pattern of the hole is centered. Or rather, this kind of center lip in the motor is centered in the hole. Not physically centering it, we're just doing that. I'm going to give it a light tighten, which, yeah, that's a start. It's not centered. Back we go. Maybe push it more this way. Yeah. You don't have to, I don't think you have to wing it by eye right now, because ultimately the brass nut is what's going to determine all this, I think. Right? The nut holding the bed, etc. Cool. Let's bring this out. Okay, that concludes step 8. Step 9 is to combine our 2 sets of plates. Naturally, I have to adjust my subtitle language from German to English. We're going to need 8 M4 hex nuts. I guess we're going to be terminating the those things. Maybe, maybe not. Possibly, probably. M3 hex nuts. And we have M4 hex nuts. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 of them. Perfect. These are thin ones, very, very thin. The flat shape, DIN 439. It's a thinner one. 8 screws, Torx button head looking, M3x8. Let me check my chart. I'm definitely going to be doing that. So this is step 9. Step 9 involves cheese head, which is the button head Torx of sorts. M3x8. Good, we have a use for these guys. Wonderful. Cheese head. M310, M36, M38, perfect. We have that here. Getting all the other hardware out of the way. M38, let's bring the first guy over here. Come on, we got you. Okay, that's dragging now. Good riddance, that's the stained one anyways. And now, so 8 screws of the M3x8 button head Torx variety, or the cheese head. GT2 pulleys. I don't have those here, I'm going to have to go get those. Of course, the pulleys have a mounting direction. Yeah. This requires brain power. And we just passed 2 hours, so I think I'm going to call it for today. It's not hard, I have to prepare the stuff and figure out exactly how many ways I can figure out how to do it wrong. And then come back and do it more. 310. So, yeah, I'll just leave it open in case anybody has any thoughts for chat, and then we'll call it for today, and hopefully pick things back up tomorrow, where we might actually have an assembled linear motion stage. That's the goal for tomorrow. A very, very small Core XY stage. Ooh. But yeah, good progress was made today. We got the first sheet. This bottom plate here is actually at the very top of the printer, so we got the entire belt system figured out. Ooh, let's check if all the bearings spin. That spins, that spins, that spins, that spins. Woohoo! So nothing's over tightened. And that's the smaller bit. So these are good. Oh, that's loose by a ton. Wonderful. Well, so what can I say? That'll set eventually. Alright. Cool. Yep. We'll pick this up again next time. Thanks for watching, everyone. Have a good one.